Hello everyone, we are Group 4 and today we will be doing our presentation on Bombardier with the chosen commodity being aluminum as a prime material in aerospace engineering.
Hello. Today we're going to discuss the Bombardier Company's overview. The company was founded on July 10th, 1942 in Valcourt, Quebec, Canada. The founder, Joseph Armand Bombardier, set his headquarters in Dorval, just outside of Montreal, Quebec. The company publicly traded on the TSX and originally manufactured snowmobiles and winter transport vehicles. As of today, they've evolved into a major transportation and aerospace company focused primarily on business aviation. Their business specialization and products include the design, manufacture, and servicing of business jets, flagship aircraft families that are both Global and the Challenger series. Their customers include corporations, governments, defense, and charter operators. They specialize in global maintenance, repair, and have an extensive support network with a focus on innovation, performance, range, and passenger comfort. Bombardier Defense supports government and military aviation needs, and they are among the leading business jet manufacturers globally. For their financial performance, their annual revenue approximately reached a US total of 9.55 billion, with approximately 18,700 employees worldwide. They boast a fleet of 157 business jet deliveries in 2025 alone. They have an order backlog of about 17.5 billion US, and their current president and CEO is Eric Martel. They've since transformed into a pure play business aviation company whose key strengths include premium aircraft portfolio and a strong global brand. Thank you.
Thanks. Our commodity is aerospace aluminum alloys. Bombardier purchases this material in several physical forms: plate, sheet, extrusions, forings, and bars. Each form is chosen based on the part it becomes. This aluminum product go into essential every major structural section of the aircraft: wings, fuselage, internal frames, floor beams, stringers, landing gear, support structures, doors, and even engine pylons. In short, aluminum is the structural backbone of the airframe, which is exactly why the grade and form purchases has to be exactly right for each applications. Here are 4 common grades our buyer work with. 2024-T3 offers a high fatigue resistance, excellent strength, and good machinability, so it is used for wing skins and general aircraft structures. 7075 and T6 is one of the strongest aluminum alloys available with excellent stress resistance. It goes into the spars, bulkheads, and other high-load structure components. 7050 offers better corrosion resistance and is used for thick structure part, and 6061 provides moderate strength with a good corrosion resistance and easier fabrication, making it useful for general fabrication needs. Choosing the right grade is a balance of the strength and weight and corrosion resistance and cost. 2 more quick points before I head off. First, packaging. Aluminum shipment arrive protected with a plastic film, wooden crates, moisture barriers, and steel banding, identification labels, and heat treatment certification. So the materials stay traceable and undamaged from the mill to shop floor. Second, classification according to Aluminum Association. These are ranked aluminum alloys identified using temporal designation like T3, T6, and T7451, which describe how the metal was heat treated and strengthened. That classification system is what lets buyers, mills, and inspectors all speak the same language when specifying and verifying material. Now I'll pass it to my teammates to cover quality and inspection.
All right, now on to the supply and demand section. So first of all, pricing for aerospace aluminum comes down to 6 specific levers. First of all, energy cost, especially electricity being highly critical in aluminum production. Second, bauxite mining and aluminum refining. Of course, the United States dollar, as aluminum is traded in USD, and the classics being transportation, tariffs, and supply chain disruptions. Now on to suppliers. So first of all, domestic suppliers include Rio Tinto and Alouette Alumina, which are affiliated and are a major supplier of primary or non-recyclable aluminum. International suppliers include Constellium in France, which is a major supplier of aluminum for the global aerotech industry. Several US suppliers, including Novelis, being the largest aluminum recycler, not as good as primary aluminum, but still can be used in the aerospace industry, and high-quality aluminum from such a supplier like Hydro from Norway. Zooming into the 2025-2026 trends, demand is climbing with overall higher demand for aircraft production across multiple sectors. Of course, the US tariffs doubled to 50% in the mid-2025, and the Middle East disruptions threaten up to 3.5 million tons of global output of aluminum, which pushed the LME, or the London Metal Exchange, benchmark prices to record highs. This in turn directly shapes procurement priorities. So first of all, first one being supplier quality management through such things as in the International Aerospace Quality Group requirements and the aerospace standards, 9,100 certifications, environmental, social, and governmental due diligence, currency exposure via LME pricing, and material availability tracked through such things such as the United States Geological Survey data. Finally, getting in a bit into the customers, demand is driven by, first of all, corporate flight departments and ultra-high net worth buyers, which are impacted by things like corporate profitability and, of course, general wealth. Another type of customer would be charter and fractional operators, which are basically businesses, which are impacted by more technical factors such as the aircraft replacement cycles, and of course government and defense customers, which are impacted by general global unrest, GDP, defense demands, and so on.
Finally, quality also has to be verified through inspection. When aerospace aluminum is received, inspection can begin with checking the documentation and visually examining the material for damage or surface defects. Dimensions such as thickness and other tolerances can also be verified against the purchase requirements. Depending on the material and specification, addition testing may be required. For example, ultrasound testing is a non-destructive method that can detect internal discontinuities without damaging the material itself. Hardness and electrical conductivity testing can also provide information about the material condition. From a human perspective, this is important because non-conforming material can result in rejection, rework, additional cost, and production delays. Therefore, quality inspection helps ensure that only materials meeting the required specification moves into the aircraft production. The next part of quality control is certification and traceability. In aerospace procurement, buyers need documentation that provide evidence that the material received meets the required specification. Material documentation can identify the alloy and temper and provide results for chemical composition and mechanical properties. A certificate of conformance also provides confirmation that the supplied material meets the specified requirements. Traceability is especially important. The material and its documentation are connected through identifying information such as lot, batch, heat number. This allows the organization to trace the material back through the supply chain if a quality problem is discovered. When we talk about quality in aerospace aluminum, it is much more simply checking whether the aluminum looks good. The material has to meet specific technical requirements. For example, ASTM B209 covers aluminum alloy sheet and plate. All of these includes requirements for different alloys, tempers, and mechanical properties. Some important technical materials are yield strength. This tells us when the aluminum begins to permanently deform. Tensile strength. This tells us the maximum stress it can withstand, and elongation. Elongation, this is where it shows us how much the material can deform before breaking. Fatigue and corrosion. Fatigue and corrosion resistance are also important considerations because aircraft structures experience repeated loading and environmental exposure throughout their service life. From a procurement perspective, this means that the buyer needs to purchase the correct alloy, temper, and product form accordingly to the required specification, rather than simply ordering aluminum.
And that is the end of our presentation. Thank you very much for your time and attention.